Good afternoon, boys.
Good afternoon, sir.
So around 30,
Good
good afternoon,
afternoon,
boys.
sir.
Good afternoon, good afternoon. Around 36 came. Let us start our class. Okay, guys. Boys, last class itself, I have told you that we have to go through the syllabus up to what we have completed, and whether we have left any topics, you have to tell me. So according to me, I have completed each and every topic. If you want to repeat any topic, you can tell me. If you want any clarifications on any specific topics, or if you need any extra input on any topics, you please inform me. Till now, no one have asked like that. So let us start our class today. It is necessary to show you the syllabus often when, because or else you will forget what you have in your syllabus. That is why I'm showing often syllabus in our class. In unit 2 we have completed stereolithography, LOM, FDM, SLS, SLM. I'm not abbreviating in full form. I think you know it well, so that I've completed in just a short form. Now the last technology is about binder jet technology. It is one of the important technology in manufacturing industries, mechanical manufacturing industries. Once you know about the working, you know why it is important. Okay, so with this, we are going to complete our unit 2. This binder jet technology, we will look it over in two way. One in general binder jet technology, and one in metal. How the metal, when you use metal, what is the characteristics of it? So just in two form, you will just look at it, and from which we will complete our unit 2 syllabus. So today our class will be somewhat lengthier, I feel. It will be lengthier, I feel. Okay, so let us start our class. If you have any doubt or clarification, please let me know at any time. So this is what our content, as usual. This is what the content we have seen for the other technology also, and same today also. What is binder jetting? How does it work? What are the important characteristics and material what we are going to use? Finally, its benefits and limitation. This is what you are going to see. And as usual, where to use? There's a thumb rule of binder jet. We're going to see. Okay, guys. What is binder jetting? Usually, I will show you this classification. You won't find the binder jet classification in this figure. Because end of the class you will know why it have not indicated here. Okay, guys. So let us start our right now. It's not working, man. Okay. So binder jet is a family of additive manufacturing process. Yes, of course, because of that we are looking it as one of its classification. Then the important point is here a binder is used for combining of the powder materials here. Do you know what you mean by binders, man? Binder? Anyone, please? What do you mean by binder?
Layers வந்து mold பண்றதுன்னு சொல்லு.
Layers mold பண்ணுவா. Mold.
So binder it's like a gums ரெண்டு லேயரும் ஸ்டிக் ஆவறதுக்கு யூஸ் பண்றது.
Okay. So I think as you're studying 3D printing, you are indicating the word layer. It is not about joining of two layer, joining of two particles to solid. Anything might be. It might be a powder, it might be a solid, or else it might be a layer. Okay. Binder is nothing but it is like a glue used to bind two particles. So that is what the thing you are going to use. Because of using binder, we are calling it as a binder jet technology. So we are using jet to spray over the powder layer, so that we are calling it as a binder jet. Okay, guys. So a binder is selectively deposit on the powder bed. So from which the bonding will happen. Finally, a layer by layer process will be happen. At last, a solid part you will get. So this is what the binder jetting is. Here, what the material we are going to use here is metals, sand, and ceramics. Yes, of course, man. What you have seen is right. We can use metal, sand, and ceramics. Okay. And important thing is here you can use any colors, different colors, combination of colors you can use. Whole pot can be made with a color, different colors. That is possible in the binder jet, but using of colors in different colors in other type of technology is not possible. Only for few areas, or else only certain colors you can use. But in binder jet, you can use any number of colors. That is the biggest difference between this binder jet and other type of 3D printing. And important here is, as I told you earlier, large sand casting cores and molds can be done through this binder jet. Okay, that is why it is one of the important technology for manufacturing area, in mechanical manufacturing area. Okay, this diagram will roughly show how the binder jet will be. It is just a front view. This is nothing but a bin to provide I'm sorry, provide material for the build platform. See here, it is keep on moving. See here, it is keep on moving, so that the powder will this powder will be provided in the build platform. This is nothing but a jet, not a ordinary jet, binder jet. Why it is called binder jet? Here you will provide the binder to the build platform. This jet will spray the binder in the build platform. So this is how it will be developed. So once a layer is over, this build platform will move downwards to the one layer thickness, and this inbuilt bin will be moved one layer upwards. This is how it will work, as like previous or other technologies. This is a complete view or else orthographic view of a binder jet technology. See here, it is a material container. You will have a material here, inkjet print heads. Yes, it is also called as inkjet, because when you use different colors, they are calling it as a inkjet. Okay, nothing other than that. They are using different colors as a binder, so that they are calling it as a inkjet. You can use any different of colors. Then recoater. Recoater is not a new word for you. Recoater is nothing but it is used to provide the powder metal on the build platform. Once the layer work completed, the next layer powder will be provided by the recoater. That is how it have been used for this also on previous technology. And this is the part that here I mentioned to show you how it is. And next one is a powder bed, or else built platform. Okay, I'm sorry, the indicator as a powder bed separately, because a layer of powder have been poured by the recoater. Next one is build platform, where the solid is builded. And finally, overflow bin. Overflow bin is nothing but the excess powder will be collected in the overflow bin. So the build platform and the overflow bin will be moved down. One layer once the work is over. Okay, and note it down. This bin will material bin will move upward for a one layer thickness. So this is how it will be work. Note a thing that inkjet print head will move in both x and y direction. So let us see how it works. First, a recoating bed spreads a thin layer of powder over the build platform. Yes, the recoater will always spread the powder over the build platform. So the next step is the inkjet nozzle. The inkjet nozzle which have a binder. It will spray over, or else it will deposit the droplets of binding agent over the powder particles. So here, um, here the recoater, what it will do, it will spread this recoater will spread the powder metal over the build platform. After that, the inkjet will spray the binder over the powder metal powder in the build platform. So what happens is it will bind together. Okay, this in full color binder jetting, the colored ink also deposited. Yes, if you, as I told you already, you can use different color as a binder, so that the material will look as like the color. The size of each droplet is approximately 18 micrometer. This size is for mentioning the binder droplets. So it is about 80 micrometer. So 80 micrometer is a very small size, which is enough to bind the powder materials. Okay, so that what you will get is you will get a very high surface resolution. Okay, guys. Once it have been completed, once a layer is completed, the build platform, what it will do, as I told you earlier, it will moves down. It will moves down. Okay, so then again the recoater will provide a metal powder, and binder jet will provide jet will spray the binder. After that, they will provide some few seconds. Then the process will be repeated layer by layer until the solid object gets completed. Okay, once the printing gets over, the part or the solid is encapsulated in the powder and left to cure and gain strength. See, here the material won't be taken immediately from the build platform. They will left it there for cure. They will take some time. They will lift it for a certain period to have a good curing, and finally you will get a high strength, high mechanical properties. That is why they will place in a powder. They place in encapsulated in the powder. Okay, guys. After the certain period, after the curing overs, the material will be removed from the build platform. Then it will be cleaned using a pressurized air, so that the unwanted powder or non-binded powder will be removed easily. So here also you have to note it down, a point that layer addition is an important thing in the 3D printing. Here layer addition between the build platform and the solid is usually not that much higher, so that it is easy to remove the solid from the build platform. But in case of other laser technologies, it is a little bit tougher to remove the finished part. Okay, once it get over, once it have been cleaned using a pressurized air, it have to be go for post process. Here the post process is on two types. One is sintered and another one is infiltrated. Um, about this we will see in a further slide. Okay, just know it. Once the process is over, you have to go for post process as like the other 3D printing technology. Here the post processing can be done in two types. One is sintering and another one is infiltrating. So we will choose any one according to the type of material what you are going to use. Let us see in further slides. So we will move to next slide. Here, once the process is over, once the process and post process is over, we can say it as it is in a green state. It is in a green state because here using the glue, we have binded the material in a room temperature, so that it is called a, this solid will be called as a green product. Okay, this have to be improve this type of product have to be improve the strength with the help of some other process so that the mechanical property will be improved, or else it will be in a very brittle form. It will break very easily. Okay. So let us see the characteristics of binder jetting. So first characteristics, printing parameters. So as like others, here the layer height is a typical one. The layer height is a typical one. Usually this is preset in the machine because we are going to use only few materials here. One is sand, one is ceramics and metal. So depending upon that, it will be preset already. Okay. Here for metal parts, it is around 50 microns. The layer height metal part is around 50 micron, and for sand is about 200 to 400 microns. So this is how it will be used here. Okay, the important advantage compared to other type of technologies, here we are not bonding the powder metal or powder material in a higher temperature. It happens in a room temperature, so that the distortion due to thermal effect is not possible in the casting. So these are the advantages for us compared to other type of 3D printing. Next one, here in the build platform, you can use the whole volume. Compared to other, you can use the whole volume, and also it is one of the largest largest printing object can be possible in this type of technology. See, look at here, 2200 into 600 but compared to other, maximum you will get 1500 higher 1500 length you can do, but here you can go for 2200 because you are using a binder here, so that it has a binder here and happening in a room temperature, so that the size of the object can be maximized in this type of technology. Okay, but it is not possible in other type of 3D printing. Okay, well, let us go to next slide. And notable thing is here no need of structure. Only few 3D printing have to be used without support structure. But in others, you have to go for a support structure. So it is also a technology. You have not to give any support. But we can use without support, you can go for any size. That is one of the advantages here. Similarly, as like SLS, selective laser centering, you doesn't need any support. Only these two you will have a no need to use any support. Okay, guys. The post processing is necessary, as I told you already, because of geometric inaccuracies. I will tell you why we have a geometric inaccuracy. I will tell you. Okay, wait. Then because of the size, and it happens in low room temperature, and we are using binder, this type of 3D technology can be used for low to medium batch protection. So the cost won't be a much difference. That is why it is mostly used in a low to medium batch production, because also its size also suitable for low to medium batch production. It is one of the part which have been made using binder jet. You can see how much intricate shape can be done easily. The size of the hole have been varied, even though it is possible in the binder jet. So that is the biggest advantage in the binder jet. We can use any shape, any intricate shape with a good outcome. But this part have been post processed to have a such a finishing. But in once it have been completed, you have to go for post process as like the other printing process. Full color, yes, I already told you. You can use any color. Any different colors can be used in a single part. Here you can use sandstone powder, PMMA. It is nothing but a polymer, as you know that. It can be used for printing. Different colors can be combined. As you see in painting, many different colors you can choose. You can choose you have an option that you will have an option to show there are variety of colors. In that you can choose your color, not only from a palette colors, you can go for option to have whole colors. From that you can selectively choose whatever you want. Like that you combine with different colors, and finally you will have some different color. That color can also be used here as a binder. Okay, that is the one of the advantages, as I told you earlier. After printing, the parts are coated with the cyanoacrylate. Yes, cyanoacrylate is nothing but it is one of the super glue. It will enhance the binding property of the material. Okay, guys, and also it will provide the color to the vibrant color to the material. Even epoxy they will use. Even epoxy they are using for the strength of the binding strength of the powder and the color appearance. Epoxy is nothing but you are using in project for materials. Like same epoxy they can use because they are a low cost epoxy and also have a property of binding of powders. Okay, guys. With this thing, we have to also note down what are the negative things. This happen in room temperature. It's an advantage, but at the same time, it is brittle in nature. It will break easily, so that it is not recommend for full functional application. For full functional application, we need a sturdy product, not a brittle. But using binder jet, we can make only the showcase product. Okay, showcase product means you can use that as a mold is nothing but it is used for making a solid object, and that can be used here because it is not a functional one. See, it is nothing but a full color print of print printed in sandstone with binder jetting. You can see here they are used many colors: 1, 2, 3, 4, 5, 6, 7 different colors, and even see the accuracy how they have been used. This such a high accuracy can be achieved with different colors also. Even it is not just like a ordinary shape, it is an intricate shape that is also possible in the binder jet. Okay, sand casting cores and molds. As I told you, it is used for sand casting cores. See, for making a sand casting core, we will use patterns. So instead of pattern, with the help of sand or silica, we can print the sand casting cores and mold with the help of binder jet. So it is one of the biggest advantage. We can once you make such a high accuracy sand casting cores and molds, the output will also have a good accuracy. So that it is one of the important advantage. Also, by using this, you can go for a low to medium size product. You can say it, you can say that you can achieve this in a low cost. Also, the speed will be increased compared to ordinary manual work. So this is one of the example for a sand casting assembly used to cast an engine block. See, such a high accuracy you have been done in the 3D printing. It is not possible in manual work. It can be achieved, but it will take long time, or else you have to spend more on what is it? You have to spend more on pattern, so that when you use same thing in 3D printing of binder jet, it is low cost, and you can achieve in a lesser time, so that our lead time will also be reduced. Next, by metal binder jet. So previously what you have seen is ordinary binder jet. Ordinary binder jet means for sand and ceramics. Now let us see about metal binder jetting. Metal binder jetting is more economical compared to other type of 3D printing machine. Yes, because we doesn't need any support. And also this binding is happening at the room temperature, so that metal will not go for any thermal distortion. Okay, here, as I told you before, the metal binder jetting was require a secondary process after printing, the post processing. Post processing here we can use for infiltration or sintering, that is, so that you can achieve some good mechanical properties, or else that product will be called as a green material that will be in a brittle stage, so that you cannot use for any other purpose. It will be only for showcase. So that if you, even if you want to use that in sand casting, you need to have some strength to withstand the pressure and the load, so that it have to be infiltrated or sintered. Infiltration, what you mean by infiltration is you have nothing but once the part finished, once the part finished in the build platform, after a certain period of time, we will take out from the platform. Okay, once you have taken out from the platform, it will be in a green state. So it contains binder and the metal powder. So binder is a weakest part in the whole weakest part of the whole product. So that to remove the binder, what we will do is we will place that in a furnace. Once you place that in a furnace, the binder will get evaporated and the only the material we will have. So the porosity of the material will be increased, yes, of course, but to reduce the porosity, we will infiltrate with the help of bronze. We will use this bronze because I'm not getting. We will infiltrate with the help of bronze, because it is one of the low temperature material you can provide easily with low cost, so that it can be infiltrated with the help of capillary action. Once it have been infiltrated, the porosity will be reduced and the strength of the material will be increased. It is one type infiltration. Next one is sintering. Sintering is nothing but as like in other technologies, we will sinter the whole product. So what happens is, the due to the high temperature, it will stick together, bind together. The material binder will burn out or else evaporate, and after that the porosity of the material will be reduced by binding of particle between each other, so that the material strength will be increased. It will reduce the porosity of the material. Guys, do you understand what I'm saying? Do you find the difference between infiltration and the sintering, boys? Hello, boys, are you there?
Yes, sir.
Be able to find the difference. Infiltration is nothing but you will place the object in the furnace, and the binder will get evaporated, and after that the material will be filled, the object will be filled with the some low temperature material, so that the porosity will be reduced. That is called infiltration. Second one is sintering. Sintering is nothing but you will place in the furnace, the binder will be evaporated, and even after that you are going to heat, so that the material between the porosity will be stick together, and finally you will form a good material. But due to that, the porosity will be reduced. Here we are not going to use any secondary material, but in infiltration you are going to use some secondary material. That is what the difference between infiltration and sintering. Okay, so it is one of the example, or else I just want to show you that it is a material, it have been infiltrated. See the surface, you're not getting any good finish, good surface finish. It will be like that because it have been porosity, and it have been filled with the infiltrated product, infiltrated material, that is nothing but bronze here. Okay, so characteristics, what is the important characteristics of metal binder jetting here? Here the important thing is, depends upon the size and shape or else design, the accuracy and tolerance will differs. That is the important thing here. Not all the product you will get the same accuracy. Depends upon the size, shape and geometry, the tolerance and accuracy will be varied. A good example is, if you have 25 to 75 mm thick it will shrink between 0.8 to 2%. But it have been when it is when the size is go above that, the shrinkage will be 3%. So it will differs. When the size differs, the shrinkage will differs. For sintering, the part will shrink up to 20% because the material here, the actual material is binding together to reduce the porosity, so that the material size will be reduced up to 20%. So you have to design accordingly, calculate accordingly. Okay, guys, shrinkage compensation you must give in the metal binder jetting. But compared to other, you doesn't need any support. Warping also happens due to you are placing that in a furnace. You have to keep in mind. Here, you can see some internal porosity also. Once you can using infiltration, you can fill the bronze in the outer surface. You cannot infiltrate throughout the product, so that there will be some porosities inside the material. So what I can say is you cannot use this material for a high-end applications. For an ordinary application, a normal application you can give, but not for high-end applications. Okay. Once you are placed for post processing in sintering or infiltration, there might be a chance for crack in the void areas. There is a chance because due to that, due to porosity, the strength will be reduced, and due to the binding, while on binding, a small crack might develop in the porous areas. Okay, sometimes they will use hot isostatic pressing. I think, yeah, maybe you have studied in materials. I don't know how many of you studied. It is nothing but a material will be uh, placed inside a container, and it will a liquid, a hot liquid will be placed, and this liquid will pressurize the powder, and finally you will form a product. So what happens is what happens at that area is this material will be pressed in a hot state, so that the material will bind together in a well manner. So that is what called hot isostatic pressing. So that you can do in such a process to improve the mechanical properties. Okay. As I show you, you won't get such a high finish. There will be some rough finish also. The finish might be RA maximum 6 micrometer, and it will be reduced to RA3 maximum 3 micrometer. You can reduce more than that. It is not possible. Sometimes you may reduce, but you can reduce, but the cost will be more. So that usually they'll go for 6 to 3 micrometer. Okay, guys. And what are the materials we can use? Full color sandstone they can use, but the important thing is it will be in a brittle state, so that it can be used for some showcasing material. Silica sand you can use for a sand casting application, and stainless steel, it have good mechanical properties, you can use for anything, but the porosity will be up to 10%. If you go for stainless steel with sintered, the porosity will be reduced. So you can see the difference. When you go for infiltration, the porosity will be more. When you go for sintered, the porosity will be reduced. But the thing is, the shrinkage will be differs. In shrinkage, when you take shrinkage, infiltration, the shrinkage will be reduced, but in sinter shrinkage will be more. That is what the difference is. Even you can go for inconel alloy, which will have a good properties. I think I have copied twice. Just ignore that. What is the benefits and limitation of binder jetting? The benefits, as I told you earlier, or else once you have been we have been gone for many slides, you might understand the benefits and limitations. It is one of the technology used for prototypes. With the lesser cost compared to other material, you can go for a non-functional prototypes. So it is a fraction of cost compared to SLM and DMLS. So one of the advantages. Next one is large parts compared to any 3D printing machine. you can make a huge parts that is possible in the binder jet. 3000, I'm sorry, 2200 length that is possible in the binder jet, but in other technologies you can go for only 1500 Then complex shape, as I told you in as I show you in color binding, there are different colors and complex shape can be possible in the 3D printing as like other. Okay, this is just comparison with the conventional manufacturing. It is possible. Then a batch production, low to medium batch production is possible because of its size and cost. You can go for low to medium batch production. Then what's the negative? Yes, of course, it have some negative negative of it. Negative is nothing but low mechanical properties because it once the process completed, it will in a brittle state. Okay, so that it have a less mechanical properties compared to other, and finishing might not be as we expect. It will be in a rough state, so you have to finish in a higher state to achieve a good finishing. And also it is not possible to get same accuracy and tolerance in all materials. It depends upon the size, shape and geometry. And finally, we have a very little material selection. Yes, we have only three: sand, ceramic, and metal. Only we have few material selection, and there are many researchers have been going through to increase the material used in the binder jet, because compared to any other technology, it is one of the low cost technology in 3D printing to have a good product. So that there are many research have been going in this area. I think in 5 to 7 years you will be used with many different metals. So these are the positive and negative of a binder jet. So guidelines: material you can go for metal, ceramic or sand. Dimensional accuracy maximum you will get zero point 0.2 or plus or minus 0.2 or plus or minus 0.3 So it will vary for metal and full color material, that is nothing but sand. Then next one is build size. So minimum you can build with some size and maximum you can go for some size. So for metal, 400 250 into 250 you can minimum you can make, maximum 800 into 500 into 400. Even this metal size 800 to 500 to 400 is not possible in other type of 3D printing. Only in binder jet it is possible. Okay, and as I told you, 2200 into 1200 600 that is possible here in the 3D printing for sand. Common layer thickness, it will be vary for metal and the sand. As I told you, for metal 35 to maximum 50 micrometer will be possible, and for full color 100 micrometer, and for sand 200 to 400 micrometer it is possible. And here there is no need of any special support. Okay, it is placed inside. I think the whole product will be developed with the help of powders. The powder will support the overhang, so that doesn't need any extra support. And also we are using binders so that it will bind together well in the first time of its process itself. Thumb rule: choose metal binder jetting to 3D printing metal parts at low cost for applications that do not require very high performance. Yes, as I told you, you cannot go for a high-end applications because it will have some porosities, so that you cannot go for a high-end applications. Only for ordinary and middle level applications you can use. Okay, guys. And for 3D printed parts, binder jetting offers greater design freedom than DMLS or SLM, as thermal effects are not an issue during the manufacturing process, since it happens in a room temperature. So thermal effect is not an issue. Full color binder jetting bars are very brittle and only suitable for visual purpose. When you use full color, you are not going to use a metal, so that it will be in a brittle state. You cannot use for a functional object, only for a showcasing. Then binder jet to produce very large sand casting cores and modes. This is what the thumb rule is. Now time to ask, if you have any doubt, man, you may ask. I have completed my presentation. If you have any doubt, you may ask, man. Guys, if you have any doubt, please ask me, man. I'll take attendance right now. I have taken attendance. Today we have 42 members present, man. So if you have any doubt, please ask me. As I told you earlier, the class is very lengthier today. I know, so that we don't have any test. If you have any doubt, you may ask me. Guys, are you listening, man?
Yes, sir.
If you have any doubt, please, if you have any doubt, please ask me. So once you don't have any doubts, I think it's 12:45. You may leave, man. Thank you, guys. And also, I want to say one word. We have completed unit number 2. See you, guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.